Hello friends, I am Dr. Satya Tripathi. In this video, I'll demonstrate how to build an equation or a function to feed experimental data using origin package. In this tutorial, I have taken example of variation of DC conductivity with temperature, which we call Arrhenius diagram. The DC conductivity is presented by the equation sigma DC is equal to sigma 0, which is a pre-exponential factor multiplied by e to the power minus EA by KT. So here EA is the activation energy, K is the Boltzmann constant, and T is the temperature. Let's see how we actually write the equation in origin, feed the data, and calculate the parameters. Let's start. So first open the origin. So as you can see, I have x-axis data temperature, y-axis is DC conductivity, unit of DC conductivity is Simon per centimeter, temperature is Kelvin. So what I have done for Arrhenius diagram, I have taken the inverse of temperature and logarithmic of conductivity value. Let's plot it. So this is basically the plot of DC conductivity with respect to inverse of temperature, which we call Arrhenius diagram. Let's see how we should write a equation in origin. First go to analysis, then go to fitting, then go to nonlinear curve fit and open dialog. You can alternatively press Ctrl Y to come into this dialog box. So press it, then it will come origin function, go to user defined, then go to then we'll create a new function here. So click on this one. So a new dialog box will appear. So I'll write, for example, activation energy, activation energy, and so so description I can leave it. So I'll go expression, it is fine. So I'll go next. So here independent variable x, dependent y. So parameter I would like to calculate, one is activation energy, another is the pre-exponential factor. So you go back to the slide and you can copy paste the steps here. So this step 1 and step 2 are required to prepare the equation in origin. So you can paste it, Ctrl V. So make sure that you put a space after each parameter. So first parameter is my sigma 0 comma EA. Be very careful about the characters that you are using. Next, I am not going to use a derived parameter here, constants are not there, so I am going for next. So next, so here it is already taken sigma 0, which unit is basically Simon per centimeter. Activation energy is here, in this case it will be kilojoule per mole, and the meaning is basically the conductivity here at high temperature, and here this is activation energy. So initial value I can take sigma 0 as, because this is log of conductivity, I can take -5 as starting, because the conductivity is 10 to -5 Simon per centimeter. You take a log, it will be -5. So activation energy I can take 50 kilojoule per mole starting. So you can initialize the value and you can see that you can calculate. Let me check, function body is empty. Yes, I did not put the function here, so you can put the function from here. So Ctrl C and Ctrl B. So you can see that if you press it, yes, you can see that y value is calculated -7.6. This is like DC conductivity. So you go next and next, then I don't want to put a lower bound or upper bound, you can put it up to your choice. So next, then next, then finish, you can do that. So this activation energy function, actually it will be created inside the origin, and you can see that code is this one and parameter is this one. I have already initialized this value, and during the refinement also, this change in value, you can also fix this data. So let me go to parameter, yes, and let me go this side. Let me see how this fits. So you can go for one iteration first. So you can see that one red line is appearing, which is the simulated curve. So you can see y value is given, error is given, dependence is given. So you can fit until converge. So do that, and next go to setting, fitted curve. To have a better range of x-axis, you can go to the custom, then go, I'll put here as 1 and this one as 3.5. I'm changing the actually x-axis scale, so 3.5. so yeah, that is done. So I'll do that. So it will take just a second, and you can see, and let me do that a little bigger symbol so that it will be visible. So this is 15, then this one I'm going to put 3. So enter. You can see a better fitting is achieved here, and what we have actually calculated, you can see. So y-axis sigma, like x-axis is the temperature. This is the equation, this is the chi-square. So log of this is sigma 0 is basically conductivity at high temperature, which you get a value 10 to the power, this is 1.6. okay, and then activation is equal to 49.82. this is in kilojoule per mole. You can convert to electron volt other energy units by multiplying the suitable factor. Okay, so in my case this will be like 0.49 electron volts, and this will be the error. Okay, and this is basically how we how we write a equation, how we calculate the parameters using data. And most of my dielectric videos I have used this method. You can write the equation as I have demonstrated, and you can fit your data. This is basically for non-linear curve fits. Also you can do power law, then peak fitting, you can also go for it. And if you feel that this video is useful, kindly subscribe and comment, and thank you for your patience for watching this video.